In this video, we'll learn the steps for sketching rational functions by hand. Remember, a rational function is any function which is expressed as a fraction, such that the numerator and the denominator are polynomial expressions. The graphs of rational functions are always interesting. In this case, there is a dashed vertical line that the pieces of the graph seems to approach but never reach. This is our vertical asymptote, and this particular function also has a horizontal asymptote. So the asymptotes are going to be important anchors to help us sketch our rational function. Here we have an example, f of x equals 3x over x plus 4. This is a rational function because it's written as a fraction. The numerator and the denominator are both polynomial expressions of degree 1 in this case. To find the vertical asymptote, we set the denominator equal to 0 and solve for x. So if I were to write x plus 4 equals 0, then x equals negative 4 would be the equation of my vertical asymptote. For the horizontal asymptotes, I notice in this case that the degree of the numerator and the denominator are the same. So whenever that is the case, to find the equation of the horizontal asymptote, I divide the coefficients of the highest degree term. So I'm going to divide, in this case, 3 divided by 1. My horizontal asymptote will have an equation of y equals 3. Oblique asymptotes occur when the polynomial in the numerator is of a higher degree than the polynomial in the denominator. In this case, there is no oblique asymptote. So now I can use Desmos.com or some other graphing utility to type in the equation form of this function. And when I do, I get a graph that looks like this, and I can check my answers. Is my vertical asymptote correct at x equals negative 4? Well, let's look at the x-axis and draw that vertical dashed line going through the x-axis at negative 4. My vertical asymptote is correct. My horizontal asymptote, let's look at our y-axis and draw a horizontal line passing through that y-axis at 3, and I can see my horizontal asymptote is also correct. Now that's the most important thing to get started by graphing a rational function by hand. We are asked to sketch r of x equals x plus 1 over x times x plus 4 by hand. This is a rational function because it's written as a fraction. The numerator is a polynomial of degree 1. The denominator is a polynomial of degree 2. To find my vertical asymptotes, I set my denominator equal to 0 and I solve for x. What's nice is this denominator is already in factored form, so I can simply apply the zero product property. And I get two vertical asymptotes at x equals 0 and x equals negative 4. So I'm looking at a dashed line going through 0 on my x-axis and negative 4 on my x-axis. Those are my vertical asymptotes. Now the horizontal asymptotes, in this case the degree of the numerator is less than the degree of the denominator, and whenever that is true, your x-axis will be your horizontal asymptote. So the equation of my horizontal asymptote is y equals 0. It will be my x-axis, and once again that's because the numerator had a lesser degree than the denominator. We have no oblique asymptotes in this case because that only happens if the numerator had a higher degree than the denominator. So there are no oblique asymptotes. There's no slanted asymptotes. So now what I want to do is look for any intercepts. To find the x-intercept, we set y equal to 0. So let's look at our given equation form of our function. Remember that r of x is another name for y. So we can write 0 equals x plus 1 over x times x plus 4. Now the only way that a fraction would ever equal 0 is if the numerator were 0. That happens at x equals -1. So that is an x-intercept, which I can graph. To find a y-intercept, we set x equal to 0. Again, going back to our original equation form, let's find r of 0. R of 0 will not exist in this case because if you look at the denominator, you'd get 0 times anything is 0. There is no y-intercept. This rational function will not pass through the y-axis, which makes sense because the y-axis is one of my vertical asymptotes. Now we determine any other points that lie on the curve by just making a simple xy table of values. Let's find x equals -5. Let's substitute -5 in place of x in the function form. The numerator becomes -4. The denominator becomes 5. So r of -5 equals -4/5. I can plot that point on my curve. -5, -4/5. Now let's see an x value of -2. What would be the corresponding y value? Well, my numerator here would be -1. My denominator would be -4. A negative over a negative is a positive. So -2, 1/4 lies on this curve. If x equals 1, the y value would equal 2/5, which can be plotted. If x equals 2, the y value would be 1/4. If x equals 3, the y value is 4/21. So you see we're getting closer and closer to that x-axis on the right-hand side. And now what I want to imagine is how would this curve look? How could I sketch the smooth parts of this curve? Remembering the curve will never cross through the asymptote. It will just approach it. So I could sketch this by hand and then check my answer by using a graphing utility. The graph would look like this. And that is the process for sketching a rational function by hand. We found the asymptotes, we found the intercepts, and then we determined some other points that lie along the curve of the rational function.